Our many agencies, many institutions are doing great job in promoting mariculture and increasing marine production. In India, in fact, mariculture was, this is very interesting. The first mariculture activity was documented in 1970s. Which agency, which institute? Central Salt and Marine Chemicals Research Institute. And what they did culture of seaweed. And after that, it was followed by many ICR institutes like CMFRI in 1980s, and then this activity started. In 1990s, SEBA, which is the pioneering agency in promoting brackish water aquaculture, and NIOT, Nations of Ocean Technology, as well as MPDA, Marine Products Export Development Authority, also significantly contributed to development of mariculture. They are still contributing, these agencies, to significantly. ICR CMFRI has become the pioneering institution in the country, which has been developing appropriate mariculture technologies in India. In fact, I suggest you to please visit the websites of these institutes and many other related institutes. You will get excellent information. There are many fisheries colleges, universities, and some of the traditional universities in the coastal regions. They are also contributing, significantly. Open sea mariculture was initiated for the first time in India by CMFRI in 2005, and open sea floating cage. This requires a lot of effort. First starting open sea cage farming and then maintaining it, that is a big job. And in my opinion, this is one of the areas where we can do a lot of investment and produce more biomass. Aquaculture technologies include seed production and farming of fin fishes, such as we should first focus on seed production and then farming technologies. That what are these steps? I told you for inland aquaculture that what are these different steps for starting and how we should proceed for composite fish farming or polyculture or other type of culture practice, right from the beginning, product preparation of pond until harvesting. Here also we need that kind of thing. People are doing, people are contributing, and very soon I think we will have, we can see the progress to a remarkable point. Cobia, pompano, sea bass, groupers, snappers, breams, number of fishes, number of other organisms, ornamental fishes, shellfishes, such as mussels, oysters, clams, green tiger shrimp, blue swimmer crab, ornamental shrimps. All these species are being studied and worked out, the technology for promoting their mariculture. Technologies of marine pearl production, very promising area. Again, seaweed farming, RAS, and integrated multi-trophic aquaculture, IMTA, live feed production, and sea ranching are also available. So, if you see, if we are developing these technologies, we are showing promising results using these technologies. That is something commendable, and I think people should come forward. The stakeholders in these regions, they should come forward and contribute to the growth of the national economy and food production from marine resources. All India Network Project on Mariculture, headed by again CMFRI, is another very good initiative. And here, they have what they have done: year-round seed production of 6 marine fin fishes. Year-round seed production. I was telling you, if you provide seed at the desired time, the culture, ornamental, mariculture is going to another scale. So it will be taken up, and you will see that we will produce more and more through mariculture in the coming years. Cobia, silver pampano, Indian pampano, orange spotted grouper, pink ear sea bream, John's snapper, they have developed the technologies for year-round seed production. So that is very significant, very significant. 27 species of expensive marine ornamental species, including 5 crossbreeds. I probably have not shown you so far about ornamental fishes status, but as a country, we are still lagging quite behind. And very small countries, they are leading, Japan, Singapore. We can contribute national income, or we can increase our exports by producing more and more good quality of ornamental fishes. We have huge potential there also. CMFRI has undertaken comprehensive efforts in this realm, successfully mapping and identifying 317 potential seaweed farming sites covering an extensive 23,970 hectare area. So they are doing their job marvelously, and a lot of areas are being identified, and the culture technologies are being provided, and culture practices are being started. Georeference 146 potential sites for sea cage farming. So potential sites, if potential sites are there, potential species are there, if their breeding protocol has already been standardized, then come on, what are you waiting for? You can have your contribution towards food supply from the marine resource. Potential of production potential of 1.13 million tons of fish per year, according to the sites they have identified. Such meticulous mappings and identifications underscore a commitment to data-driven planning, and that is the commitment of these institutes like CMFRI and other agencies involved to boost fish production. In fact, India is currently in a very good state in fisheries and aquaculture, and it is showing tremendous growth in all the sectors. And among all the sectors of fisheries and aquaculture, mariculture is the most promising sector right now. So if you are investing more and more in mariculture, it may fetch you very high returns in the coming days. So these are few of the systems which are shown here. RAS, a little bit of RAS I have already explained to you. Here the same thing at different scale, IMTA, and then marine fish larviculture at Mandapam, and then harvest of cobia they have shown from sea cage. Marine finfish culture. In India, we did not give much attention to developing breeding and culture technologies for marine species. We have been busy focusing more on inland waters, but now since freshwater availability is a problem, and we have tapped almost full potential of the freshwater for aquaculture. That is why the pace of growth has slowed down. So, but now we are developing culture technologies or breeding technologies for other species also. Earlier we were having for only one or two species like Cletus calcarifer, but in the recent past what we have done, success was achieved in the breeding and seed production of cobia that I have explained earlier, also silver pampano and other species that we discussed in the previous slide. Marine ornamental fish culture. On a global basis, a lucrative marine ornamental fish trade has emerged in recent years, that we all know, and marine fishes are usually sold at a relatively higher price. They fetch very good price in the international market, and recently CMFRI has successfully raised hybrid clown fishes. They have very good demand, or designer clowns. The designer clowns such as Picasso, Platinum, Snowflake, etc. are highly sought after varieties in the domestic as well as international markets. In fact, if you nowadays government is promoting ornamental fish culture like anything. If you start ornamental fish culture, especially in marine areas, and if you have a little bit idea of selective breeding and genetic manipulation, or there are other methods also by which you can have different strains, different varieties showing different morphological patterns, then you can get very good price. These are some of the pictures which are shown: Picasso clownfish, designer clownfish, snowflake clownfish. Sea cage farming. sea cage farming, that can be done at very large scale. Sea cage farming has been expanding in recent years globally, we all know, but in India, the growth is not that significant. Cage culture has made possible the large scale production of commercial fin fish. I told you that we have to go here for large scale production that needs investment, but ultimately that way you get very good produce. So, uh, this is one of the most efficient and economical way of raising fish in um, marine environment. Open ocean you can raise. When compared to many countries in the Asia Pacific region, India is still in its infancy. I told you that we have not done so much in cage culture. But as I told you, there are certain experiments which have been done by CMFRI, and other agencies are also doing, other institutions are also doing, and there are encouraging results. And in fact, if we provide proper guidelines, and if we have a good scientific framework for this, then we can have cage culture and we can get good produce from this. CMFRI introduced 6-meter diameter cages made up of GI framework and HDPE sheets, and yielding 2 to 3 tons of fish per cage per cycle. That was, you can say experimental, but if you start doing this, then you can improvise. Always you have the scope of improvement, and in the culture technology also, and the type of species you are doing in having raising in the cage, and feeding strategy, nutritional and feeding strategies, other aspects which can contribute to fish growth. Cobia, sea bass and spiny lobsters were the major groups employed for farming in the sea cages. Recently, small scale cage farming in lakes, in fact, there are many big reservoirs and lakes where cage farming has also been started, and people are doing, some are doing it on experimental basis, some are doing it on not at very large commercial basis, but you will get to see the cage farming, and there are some small sector stakeholders who are also utilizing this cage culture for fish raising. So, these are the species which I have just described. They are being used. Then mussel farming. I told you, if you remember, mussels or mollusks in general, they are the major species animal groups which are being raised in mariculture. So, mussels are mostly found in littoral and sublittoral zones in clusters on various substrates that we all know. Two mussel species along Indian seas, Parna viridis and Parna indica, are very important. Parna viridis is distributed along the north and south of east coast and the southwest coast of India. The brown mussel, Parna indica species, is found along the southwest coast. So, according to the region where you wish to start, and culture of these mussels is very popular, and that is being practiced. Institute has developed technologies for culture of bivalves like raft method in bays, in shore waters, rack method in brackish waters, estuaries, or long line method. So, you have the methodology, the protocol, the recipe for culture of these mussels, and this is not as challenging as in case of finfishes. Here, mussels can be raised very easily, and they give you good produce. Low value, high volume seed production technologies are needed for hatchery production of mussel seeds for farming. And the major challenge here is the availability of desired number of seeds at the desired time, quality seeds. So, we need to work out, we need to improvise this area so that this can be popularized even at a large scale. CMFRI has already succeeded in the low cost production of mussel seeds in hatchery, but it should be commercialized in such a manner that it is popular among all the stakeholders, especially the small scale sectors. Edible oyster farming. CMFRI has developed methods for edible oyster, Crassostrea madracensis, culture and has produced a complete package of technology, in shallow estuaries, bays and backwaters. Whatever kind of water body you are having, if you are having the method, if you know the culture technique, uh, you can work out whether this culture technique is going to work in the type of water body where you wish to start these edible oyster farming practices, or for that matter any other culture practice. Pearl oyster farming, very fascinating one, and fascinating to everyone that we are producing jewelry out of oysters. Marine pearls are obtained from the pearl oyster Pinctada fucata, very popular. Success of production, of cultured pearls was achieved in 1973, way back. Raft culture, again the same culture techniques. Rack culture in nearshore areas are the two commonly methods adopted for rearing of the pearl oysters, and there are many people who are doing very successful culture of these pearl oysters. Pearl production technology still remains to be commercialized at large scale in India. We need to expand it. People have succeeded, people are doing it very well, but we need to commercialize it, at large scale. Research is also directed towards development of technology for in vitro pearl production. In vitro it can be done, but getting pearls from natural um, uh, um, oysters, that is something different. Seaweed culture. About 60 species of commercially important seaweeds with a standing crop of about 1 lakh ton occur along the Indian coast. We are not so much aware, especially in the northern part of the country, especially in the inland regions, about the importance of the seaweeds. But if you see, then seaweed production is increasing in many of the countries, and they have a very significant utility, directly or indirectly by human beings. Seaweed products, like here you can see the importance. Agar, algin, carrageenan, liquid fertilizer are in demand in global markets, and economically viable seaweed cultivation technologies need to be standardized and developed and popularized in the regions where potential sites for seaweed culture are there. Many agencies are already working and providing the know-how, but we need to popularize it more, to involve more and more people in this kind of culture practice. Recently, culture of carrageenan yielding seaweed has become very popular due to its fast growth and is being cultivated extensively along the Tamil Nadu coast. So, if the culture technology is demonstrated to the stakeholders, and the entire culture period, right from putting in the seed and getting the harvest, then people will of course come up. You provide the know-how, agencies will provide the know-how, and the culture practice farming of these seaweeds or any other organisms will keep pace with the demand. IMTA, now integrated multi-trophic aquaculture. IMTA is the practice which combines in appropriate proportions what? The cultivation of fed aquaculture species, finfish shrimp, fed aquaculture species where you need to feed them, with organic extractive aquaculture species such as shellfish or herbivorous shrimp, and inorganic extractive aquaculture species such as seaweed, to create balanced system for environmental stability, or biomitigation, you can say, economic stability and social acceptability. So, in IMTA, we as we were doing in polyculture, to um, utilize all the niches, all the resources available in that region. Here we are aiming to utilize all the space in such a manner that with minimum of inputs we are getting maximum utilization of the habitat and getting maximum biomass, and that should be economically viable as well as socially acceptable also. This concept is being adopted in cage culture, especially in cage culture, these IMTA technology is very significant, wherein appropriate proportions of finfishes, shrimp with shell herbivorous fish are integrated with seaweed farming. So, finfish, shrimp, herbivorous fish and seaweed farming, everything can be done together. This technique, 16 rafts of 12 by 12 feet size installed around 6-meter dia cage, has proven to double the yield in one cycle, 45 days. So, if you are utilizing IMTA, you are getting much more production. Of seaweed farming, additional 176 kg per cycle with commensurate income enhancement. So, that is one of the latest reports. So, these such technologies, such modern technologies which can help you get more benefit out of the same resource, we should go for this kind of culture activity and produce more biomass and make more profits. The technology is currently adopted by more than 150 farmers. See, I was telling you that if you are providing every complete recipe for any farming, people will come forward to take it up. And here you see more than 150 farmers in the Park Bay region have already adopted. And I am quite sure by seeing these 150 farmers, many others will also join, and maybe this can be done at a very large commercial scale, and India becomes one of the main leaders in production of mariculture production. Conceptual diagram of IMTA, that how it works. I have taken it from one of the agencies here, and here you are having all kind of organisms here, like crustaceans, fishes, seaweeds and other things, in order to utilize completely all the resources present in that ecosystem in a very sustainable and eco-friendly manner, in order to get maximum biomass production, whether in terms of shellfish, fish or finfish or seaweed. So, this type of modern aquaculture technology should be adopted and promoted in order to popularize the mariculture. Policy support for mariculture development. We have very good policies for mariculture development, and in fact, this is one of the agencies which is playing very important role in the growth of fisheries and aquaculture activity currently. NFTB, they drafted National Mariculture Policy in 2019. 2019 reference is given. National Mariculture Policy of NFTB focuses on sustainable expansion. Sustainability is always a concern, and that should be taken care of. Optimized leasing, licensing practices, mariculture systems, species selection, environmental health, almost everything related to the promotion and setting up of a mariculture system. Seed and feed resources, very important one. Animal health management, certification standards and market initiatives. In fact, certification standards should also be taken care of in a very well manner, because ultimately if your produce is not accepted by any country or any region, any market, then there will be huge loss. Currently under considerations within the Ministry of Fisheries, the policy aimed to harvest around 4.1 million tons of marine fish annually through cage culture alone by 2050, and that is achievable. In fact, maybe we can do it even earlier than that, with 1% of the country's extensive coastline dedicated to mariculture. Just see, with 1% of the country's extensive coastline dedicated to mariculture. So, we have huge potential. It depends on how and when all the factors they work together in a coordinated manner to get the excellent growth in mariculture. That's it in this lecture. Thank you so much.